All right, guys, so the first skill we're going to be talking about is the Pythagorean theorem. So there's a bunch of ways that we can solve for missing pieces of a right triangle, and the first one is the Pythagorean theorem, okay? And it tells us that a squared plus b squared equals c squared. And the most important thing that you need to take away from this equation is that the c squared is on one side of the equal sign, and that c always has to go with the hypotenuse. So if we look at a problem like this, it lets us solve for this missing side, right? My Pythagorean theorem says that a squared plus b squared equals c squared. And once again, the most important thing is I need to make sure that my c squared is my longest side. It's my hypotenuse, okay? So x is going to go in over here where c is, okay? And then these two don't really matter. I can put either one wherever I want. So I can say 4.3 squared plus 7.4 squared, or I can flip those. It really doesn't matter. And to solve from here, I'm just going to go ahead, I'm going to get my calculator. 4.3 times 4.3, 18.49. 7.4 times 7.
I need to get through this other class.
0.4 is 54.76. Okay, and now I just need to solve for x. I'm going to combine my like terms. Gives me 73.25. And then my last step, to get x by itself, I'm just going to take the square root on both sides of my equal sign. X is equal to 8.56.
So we're still dealing with right triangles and finding missing sides. Now the reason that this is a good Pythagorean theorem problem is we have 2 out of the 3 sides, so we can use our Pythag, which is our a squared plus b squared equals c squared. And like Mr. Matthews just mentioned, the most important part is that c must be the hypotenuse. It's your longest side, but it's also always across from the right angle. The right angle kind of points to the hypotenuse. So over here I know that it's pointing to the 14, so I know my 14 has to be alone over there squared, since that's my hypotenuse. So x squared and 13 squared will just go in for a and b. So x squared plus 13 squared. And now we just have to solve for x, but now x is in a slightly different spot, so it's gonna change just a little bit. So I'm gonna have x squared plus 13 times 13 will give us 169. 14 squared is 14 times 14, which will give us 196. We need to keep on solving for x, so I'm going to subtract that 169 from both sides. And I'll end up with x squared is equal to 27. And I now need to take my last step, and I'm going to take the square root of both sides, which will leave me with x is equal to the square root of 27. Now if I do the square root of 27, it gives me this big old decimal, and from now on, this is really important for the SAT. We don't want the decimal, we want to reduce this radical. And I want us to remember the El Chapo example. We're gonna break down this number into factors until we find a pair of 2 numbers, El Chapo and his buddy, that's gonna help him escape. So I know 27 can be broken down with 3 times 9. I haven't found a pair yet, so I need to continue to break it down. That 9 can get broken down to a 3 times 3. Now at the bottom of the tree, I see at least 1 pair. So I'm going to circle a pair of my 3s. And like the El Chapo example, his buddy tries to distract the guards but gets shot and dies. But El Chapo escapes outside of the radical. He's outside of the square root now. But that 3 didn't have a partner. He didn't have a friend to help him escape. So that 3 will stay in there. So your final answer is just that side x is 3 times the square root of 3. 1.
Okay guys, so we started talking about Pythagorean theorem, and one of the great applications of Pythagorean theorem is it can really help us find the distance between 2 points. And this is really easy if I'm given a graph, right? I'm just going to take this line here, and if I want to find the distance of this black line, I can just turn it into a triangle. Okay, once it's a right triangle like this, I can just count my sides. From here to the corner is 1, 2, 3, 4, 5, 6. And from here down to the bottom is 3. Okay, and so now I've got a triangle that's got one leg that's 6 and one leg that's 3. So I can use my Pythagorean theorem with these numbers. And once again, we need to make sure that our hypotenuse, our longest side, goes in for C, and we don't know what that is yet, so I just left that as C. 3 squared is 9, 6 squared is 36. When I add these together, that gives me 45. And to get C by itself, I'm going to take the square root on both sides. That leaves me with C is equal to square root of 45. And just as Mr. Bakke showed a minute ago, I'm going to split 45 up into factors. I can find this as a decimal, but all right, sorry for the technical delay. Just like Mr. Bakke showed, we're going to take 45 and we're going to split it down into its factors. 45 is 9 times 5. Okay, I can't split 5 down any farther, but 9 is equal to 3 times 3. Okay, so my factors here are 5, 3, and 3, and here's my pair. Okay, one of these 3s is going to distract the guard. He's going to get shot, but the other 3 escapes jail. So now that 3 is on the outside of the prison. 5 doesn't have a buddy though, so he's stuck inside. And my distance between these 2 points is just 3 times the square root of 5.
Now this is a very similar problem to what Matthews just did. What is the distance between points 2, 3 and 7, 10? The only difference is over here, the 2 points were already plotted and we already drew a nice line connecting them. We should start the same process. We're just not going to have a nice grid for our picture. But we still know that this represents 2 points on the coordinate plane connected by a line. And at one end, I'm going to put the 2 and the 3. And the other end, I'll put the 7 and the 10. Now, just like Mr. Matthews drew a triangle to make it a right triangle for Pythag, we're going to do the same exact thing, but we're going to have to get a little more creative for the 2 sides of our triangle. Okay? And we're back. So we're still going to draw the triangle, but now we need to figure out this side and this side just from our 2 points. Now we know that this is an x value and that's a y value. This is x and that's a y value. Y values tell us up and down on the coordinate grid. So if I take my 2 y values and subtract them, subtraction always finds the change or how big something is like this. So I do 10 minus 3, that's going to give me 7. And I put that on the up and down because y values always tell us about the up and down vertical. My horizontal left to right will be found from my x values. I'll once again subtract 7 minus 2, and I'll get 5. And now I have enough information to actually find the distance of my original pink line here. So I'm going to do 5 squared plus 40, oh, not 40 now, I'm getting ahead of myself, plus 7 squared is equal to c squared. 5 squared is 25, plus 7 squared is 49, is equal to c squared. 25 plus 49 is going to give us 74, is equal to c squared. My last step is to take the square root. So c will equal the square root of 74. Now, just like we've been talking about, we have to reduce this radical. So I'm going to break this down into 2 times 36. Nope, not 2 times 36, 2 times 37. And I can't break 37 down anymore. And so I don't have a pair for either of those numbers, so I can't actually help anyone escape. Your answer is just going to be the square root of 74.